Hello and welcome to Advent of Code 2024, day 25. So this is the completion of the Advent of Code 2024. So you can look at this, and so this day is called Code Chronicle, and well, just kind of a recap to day 24. That this is it was a really hard problem, and I know many people struggled with it, me included, and I just craved that the last puzzle would be something more straightforward, and yeah, it was. So let's just read through this and check out this last day of this Advent of Code. So, out of ideas and time, the historians agree that they should go back to check the chief historian's office one last time, just in case he went back there without you noticing. So when you get there, you are surprised to discover that the door to his office is locked. You can hear someone inside, but knocking yields no response. The locks on this floor are all fancy, expensive virtual versions of 5-pin tumbler locks. So you contact the North Pole security to see if they can help open the door. So 5-pin tumbler locks is kind of, yeah, it's this like this, that they have kind of spring-loaded pins. And when you insert a key, the key has grooves in different heights, and they kind of pushes the pins, and the goal is probably to get the pins to align with this line here. Yeah, we can see it here that so when an incorrect key, it looks like this. When it's a correct key, it looks like that. So that is basically what this puzzle is about. So yeah, unfortunately they lost track of which locks are installed and which keys go with them. So the best they can do is send over schematics of every lock and every key for the floor you're on. And that is also your puzzle input. The schematics are in a cryptic file format, but they do contain manufacturer information, so you look up their support number. Our virtual 5-pin tumbler product, well, that's our most expensive model, way more secure than, yeah, you explain that you need to open the door and don't have a lot of time. Well, you can't know whether a key opens a lock without actually trying the key in the lock, due to some quantum hidden variables, but you can rule out some of the key lock combinations. The virtual system is complicated, but part of it really is a crude simulation of a 5-pin tumbler lock. Mostly for marketing reasons. If you look at the schematics, you can figure out whether a key should possibly fit in a lock. He transmits you some example schematics. So yeah, so the locks are schematics that have the top row filled and the bottom row empty, and the keys have the top row empty and the bottom row filled. So if you look at here, we can see that, well, this is a lock because it has the top row filled, and this is a key, has the bottom row filled and the top row empty. Yeah. Yeah, if you look closely, you'll see that each schematic is actually a set of columns of various heights, either extending downward from the top or for locks, or upward from the bottom for keys. For locks, those are pins themselves. You can convert the pins into schematics to a list of heights, one per column. For keys, the columns make up the shape of the key where it aligns with the pins. Those can also be converted to a list of heights. So you can say that the first lock has pin heights 0, 5, 3, 4, 3. That will be kind of, if we look here, we will kind of exclude this row, and we will do the same for the keys. So then we have kind of We have 0 here, we have 5 here, we have 3 there, we have 4 there, and 3 there. So that's a kind of... And the first key, which is this, and this from the bottom up, we will kind of exclude this row. So we have 5, we have 0, we have 2, 1, and 3. So that's the basic layout. These seem like they should fit together. In the first 4 columns, the pins and keys don't overlap. However, this key cannot be for this lock. In the rightmost column, the lock's pin overlaps with the key, which you know, because in that column, the sum of the lock height and key height is more than the available space. So you see here that there are this column actually overlaps, because there are 3 there, there are 3 there, and it's only 5 spaces available, so it kind of overlaps with 1. So yeah, so in this kind of, this is the kind of test input that we will use, and converting the locks to the pin height for that would look like this, and converting the keys should look like this. So there is obviously, first when I saw it, I thought to myself, well, is this a grid problem? Well, it's actually not. I would say that this is more or less a parsing exercise, because it's you could actually parse these kind of locks and keys to and just keep the grid layout of them, and then just kind of see if they fit together somehow. But the more easier way is actually to do it like it's proposed here in the text, that you should try to organize these grids as columns. That you should kind of, well, if we take this, let me just show in a more, yeah. So let me just delete this. Yeah. So if we kind of, if you have it like, yeah, let's say that that we have our grid is like this. We have five dots here. We have kind of pound signs, pound sign. So let's say that this is a key. In this column we have 5. In this column we have 1. Yeah, my drawing is not that perfect. In this column we might have 3, and let's say in the last we have 2, and we have 1 in the last. Yeah. So this should kind of translate then to 5, 1, 3, 2, 1. But what we need to do, but it's more easier if we can actually transpose this grid into kind of a layout instead of having the lines here like this. We should have them column wise instead. There is a very good method, actually a good function in Python that you can use, that you can actually interpret kind of a grid which have rows like this in column wise order instead. So you can kind of if this is a grid, we can actually call something called zip on them, and then you will kind of get the result back would be kind of separate lists with with these as columns instead of rows. So you kind of would turn it. You would kind of, what you do is actually turn the grid around kind of 90 degrees clockwise, and you kind of read them in column-wise order instead. But unfortunately, we don't have that in C#. So, I mean, but I have a kind of a extension method in my AOC which does basically the same thing. But we want to kind of create this kind of, and that was my intention when I read this problem the first time. We should have this in this format. So the way I visualized it before I even started to code is that, well, this will be kind of we will have a list of ints for locks, a list of ints for keys. Then we could have something, and the actual calculation part is very small in this puzzle. So let's just jump over to the code. So we start with getting our blocks, and yeah, well, okay, I should have that, but okay, it's not. Yeah, and we should do the test input here. So we have our blocks, and we want to define our locks to a list of ints, and our keys is a list of ints. And yeah, I do a split by double new line. We can just look at this test data. I need to copy it first. Yeah, so this is the test data. So we want to kind of, we have a double new line here, so we kind of want to read them in blocks of grids basically. Then we do a for each block in blocks. We will kind of do yeah, we will. Why it's actually, was it removing that? Yeah, so we will kind of, we take each block and split that into lines, and these lines will be like our kind of lines that we should go through. And what we are going to do then is this transpose thing. That's what I actually show you. So this is kind of equal to the link to the Python zip method. So it will kind of go through this list. It will take this kind of string array and turn it 90 degrees clockwise, and then read the rows, and then we will have kind of, and then the rows will instead be columns. So you will get it in that order instead. Yeah, so that we will do. Yeah, so now when we have our grid, what we do here is we kind of, you're checking if the grid has, if the first row in a grid is all pound signs, then we know this is a lock, otherwise it's a key. So what we will do is kind of, we will kind of count how many, how many pound signs we have for each row, and that will kind of be our list, our locks and our keys. So we will kind of in that code will create this structure like that. Yep. Okay. So I mean that was the parsing exercise, but I actually tried a couple of different options when doing this. First, I tried to do it one way, and then I tried to a couple of other. So I had a couple of false starts actually, but this was what the end result looked like. So, and I think this is a pretty straightforward way to do it. Also, the actual calculation part of this example is pretty small. So we will have some kind of a total variables. We call it number of key pairs. We will do for each lock pattern in locks, for each key pattern in keys, and if the lock pattern. So now we actually use the zip function in C#. That doesn't actually do the same thing as it does in Python, but the zip function will actually apply a specified function to the corresponding elements of two sequences producing the result. So that's what we want. We want to kind of take the lock pattern and the key pattern. These will kind of be the X and Y, and we want to check at each of these column Y. So let's say that we have this kind of let's say that the locks. Let's say that wait a minute. We will do it like this. So let's say that we have locks that kind of looks like the lock. The lock, if the locked look looks like this, like 5, 3, 2, 1, 3, maybe. Yeah, I need to comment it out, otherwise my Visual Studio will freak out. And let's say that the key is 0, 3, maybe 3, 4, 2. So for each of those that we will take, let's say the X is the lock and the Y is the key. So the X will be in there. So we take for each item in that list, we will kind of do. We will compare this one to this one. So we take 5 plus 0. If that is less or equal to 5, and that it's less than equal, it will kind of be 5. So that will turn out okay. And this column will take 3 plus 3, which is 6. Yeah, that's not good. So that means that this key will not be. We will check that all of these should be less or equal to 5. Otherwise, we will kind of discard this key. So if that's the case, we will kind of update our counter here, and we will, in the end, we will just do. We will kind of output our result as normal. So that will be number of key pairs. So so running this should give us 3. Oh, sorry, I switch project. That was my real input example. Yeah, so we got 3 here. So we go back, so we got 3. Yeah, and this was my result for my real input. So as normal for day 25, the part 2 is actually not a real puzzle. So code-wise, we are kind of done. And you can find my code on GitHub if you want to look at and test it yourself. So let's continue on here and end this year in this fashion. So you and the historians crowd into the office, startling the chief historian awake. The historians all take turns looking confused until one asks where he's been for the last few months. I've been right here working on this high priority request from Santa. I think the only time I ever even stepped away was about a month ago when I went to grab a cup of coffee. Just then the chief notices the time. Oh no, I'm going to be late. I must have fallen asleep trying to put the finishing touches on this chronicle Santa requested, but now I don't have enough time to go visit the last 50 places on my list and complete the chronicle before Santa leaves. He said he needed it before tonight's sleigh launch. One of the historians hold up a list where they've been using the whole time to keep track of where they have been searching. Next to each place you all visited, they checked off the place with a star. Other historians hold up their own notes they took on the journey, and as historians, how could they resist writing everything down while visiting all these historically significant places? The chief's eyes get wide, and with all this we might just have enough time to finish the chronicle. Santa said he wanted it wrapped up with a bow, so I called down to the wrapping department and, hey, could you bring it up to Santa? I'll need to be in my seat to watch the sleigh launch by then. You nod, and the historians quickly work to collect their notes into the final set of pages for the chronicle. So, if you have completed all the assignments, all the puzzles in for every day of this Advent of Code, then you would also have this button here. Otherwise, you have to go back and finish the puzzles that you have not completed. And otherwise, you cannot click it. Otherwise, you will not have this link. So let's just deliver the chronicle again. So this is the final ending page for Advent of Code 2024. So using the notes from the places marked by all 50 stars, the historians finish the chronicle, wrap it, and give it to you so you can bring it to Santa before the big sleigh launch. Santa is already in the sleigh, making the final launch preparations when you arrive. You try to hand him the chronicle. Oh, sorry. But he doesn't take it. Ho, 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 he laughs to himself. What gift isn't for me? It's for you. That gift isn't for me, it's for you. That chronicle is a record of all the places you have been and people you have helped over the last decade. Thank you for everything. And with that, Santa takes off on his sleigh to deliver the rest of this year's presents. Yeah, so this is the final calendar that you will see in this. And this, as it said, is the 10-year anniversary of the AOC. And yeah, so this will be my last kind of solution video for this year, as this has been the first time I've tried to do videos about Advent of Code. Some of the videos has probably been a little bit sloppy in the sense of that that English is not my natural language, so I sometimes have trouble describing things maybe. But I think I've kind of in a learning stage at the moment. So I'm thinking I will actually do some kind of revisiting video about these puzzles. And one thing I am thinking of doing is kind of going through each and every day, and see which of the days is actually solved by LLMs. That could be a kind of a scientific exercise. So just kind of keeping an Excel sheet of which days can ChatGPT solve, which days can Claude AI solve, and so forth. So that's a video I think I will do. Also, I have a few of my puzzles could be improved, I think, and I will actually kind of thinking of if I can think of better ways to do them. I will probably do a kind of a compilation video about that as well. But otherwise, this year's Advent Code is over. So and I hope to see you again soon. And if not, you can always go back and watch any of my previous videos. And I do really appreciate any comments. That could always be helpful. So yeah, this is me signing off Advent.Code 2024, and it's kind of only 5 days left of the year. So let's see what 2025 has in store. Bye bye.